mention around heat budget, and something about the insolation patterns. Insolation patterns. What have been the changes and how it impacts us and so on. So I'll teach something to you first, and then you can get into some question discussion. Okay. Now, heat budget mein, I hope you know the data here. Okay, what is the incoming radiations? So we have got 35 is the albedo loss, 15 absorbed by the atmosphere, 50 is what is absorbed by the earth, and as we have the outgoing energy mein, some amount goes directly outside. We have clouds, some of it goes as the latent heat absorption, some goes as sensible heat absorption, some is a part of re-radiation component, and all of this ultimately also is lost to outer space. So I believe this data you have and you know. What is the heat budget? So 50 is the long wave, absorption. Okay, and this is latent heat, radiational heating, reheating 15 units. We have got 20 units. We have got another 15 units here. Okay, plus all of this together, finally we have again losses. So if you look at these numbers, you should be able to recall most of these. No. This is 15. This is 10 here. 30 and 20. Yes, 10 here. Okay, so this is how the radiation outgoing rate. So this you know. Remember one thing, that you can mention this, that the above you can say figures, you can mention as the work of Hidor, and we also have according to Trevartha. There are some variations here, don't bother about it. Just remember the above figures are based on the works of Hidor and also Trevartha. This kind of detailing helps you, okay, make your answers a bit more technical in nature. Okay, Hidor and Trevartha's work. Acha. Iske alawa, I would like you to know something about the insolation patterns. The insolation patterns. Okay. Now see, in general, the net radiation, the influx and the outflux, okay, from Earth and atmosphere is equal to 0. In general, the net radiation, the influx and outflux for Earth and atmosphere system is equal to 0. But there are three types of variations. There are three types of variations. We have variations on the basis of height. Okay, so we have some data for surface values, and we have some data for upper atmosphere, okay, values. This is one variation. The second variation is the latitudinal variation. Latitudinal variations. Latitudinal variations. So we have in the polar regions and high altitudes and high latitudes. We have in the equatorial regions, and we have in the tropical areas. So tropical areas, approximately 35 degrees, 40 degrees, north and south. So polar regions, 80, 85 degrees and beyond. And equatorial regions, 0 degrees. We have latitudinal variations of insolation and radiation. And the third is, okay, the surface specific variations. As in on the land, on the oceans, over the ice sheets, okay, over the forests, okay, So these are the three type of variations in the insolation, in the net insolation or in the net gain or loss. Are you all keeping pace with me? So if I look at the insolation patterns, in general, the net radiation for the Earth and atmosphere is 0. So this fact you know. This fact you know. And this is the basis of studying the heat budget, the heat budget balance. But then there are three type of variations we have in the insolation. Variations on the basis of height. Surface pe kya hai? And upper atmosphere. Upper atmosphere means beyond 800 kilometers kya hai? Okay. There are latitudinal variations. Some values for the polar regions, some value for the equatorial regions, and some value for the tropical regions. And third, we have the surface specific variations on the land, on the oceans, on the ice sheets, and the forests. So yes, so what does man do? Okay, man's impact kya hai? Man's impact yahan par hai. Man's impact is disruptions, okay, on the surface, and disruptions based on the locations and the altitudes. So man will change the amount of ice cover. Man changes the amount of forest. Man changes the nature of the ocean surface. Man is modifying the land. Okay, so impact of man is actually here. And to some extent, it's also more in the tropical areas. So because of albedo issues, it is also in the polar regions. Much of the variations are related to the surface aspects. Okay, so human aspects I'm not ignoring, but fundamentally, these are the three components of insolation variations. Now, what I want is now, please open up your Savindra Singh climatology, and we are looking at page number 38. So now, this is one of the diagrams I want you to look into. Yes, okay. So we have the maximum insolation reaches the outer surface of atmosphere at the North Pole at the time of the summer solstice, while the maximum insolation is received at the ground between latitudes 40 and 34 degrees on 21st June. So the dotted line is on the outer atmosphere. So outer atmosphere mein the maximum we have is here. This is the June, the summer solstice. It says here, summer solstice. And on the surface, the maximum that we have is in the 30-40 degrees. 30-40 degrees here. Again on 21st June. So the surface variation is maximum for 40 degrees north, and of course also for the south. And for the upper atmosphere, it is going to the polar regions. This is one of the conclusions that you need to have. Okay, this is one conclusion here. The second conclusion is that on the basis of insolation, the globe is divided into three zones: the low latitudes or the tropical zone, the middle latitudes, and the polar zones. The polar zones may maximum and minimum insolation. Okay, and it might become zero because of absence of direct solar rays. That's because of the summer conditions that we have. Yahan par dekho, the polar regions, 90 degree northwards. So this part is zero insolation for the polar area. This is the polar nights, the polar winter season. There is no insolation in the polar areas. And if you look at the middle parts here, the middle latitudes may, the middle latitude receive the maximum in the summer solstice in the northern hemisphere. And southern hemisphere, you will have it in the vernal, you'll have it in the winter solstice. Okay, in December, southern hemisphere, and the equatorial regions, tropical regions, and the rest. So again, this is related to maximum equator may we'll have two peaks. Equator, you can see this is one peak in the equinox and the second peak on the other equinox. September equinox, and we have the March equinox. Okay, so I would like you to know this as the second part of the discussion. The third discussion is, if you come towards what are the other variations, the variations related to the net radiation balance. Look at the sentence here. Okay, it says, it is apparent from the aforesaid discussion that the net radiation from the whole globe is at least theoretically zero, but this is far from the truth. The net radiation in terms of theoretical value, it is zero, but this is not the reality. Okay, why? Because of two things. So it's summary here. This is one summary, this is the second summary. So net radiation on the Earth's surface, there's energy surplus in the zones 20 degrees north and 20 degrees south. The net radiation rapidly decreases, okay, beyond the low latitudes. The net radiation becomes practically zero near 70 degree latitudes, and the polar areas are zones of perennial energy deficit. This is for the surface. Whereas if you talk about the atmosphere, what is about the atmosphere? The pattern is here. The pattern is there is surplus where 40 degrees north and south. इसमें surplus किधर है? 20 degrees north and south for the surface. For the atmosphere, it is 40 degrees and 30 north and south. The northern degrees have deficit radiations, and southern high latitudes also have deficit radiations. Okay. So in your answer, if I ask you, how does the radiation vary? Okay, and what are the influences? Now I'll give you the question around which your discussion, okay, will develop. Question is, though net radiation of the globe is zero theoretically, okay, there are regional variations. There are regional variations in net radiation. Okay, discuss. Though the net radiation of the globe is zero theoretically, there are regional variations in the net radiation. Discuss. Okay, so your introduction will be, okay, that a sun is the primary source of all heat and energy. Okay, the earth is mostly maintaining its temperature, discounting the present global warming. Earth acts as an efficient heat engine, and theoretically there is a radiation balance for Earth. Okay, having said this, the sun is the primary source of all heat and energy. Earth is mostly maintaining its temperature. If I discount for the global warming, Earth acts as an efficient heat engine, and theoretically there is radiation balance for the Earth. Okay, so now you can quickly draw the heat budget. Okay, so incoming radiations, outgoing radiations, show the picture. Okay, how much is absorbed where, how is energy lost to the atmosphere, and again from the atmosphere. So there is radiation balance there is radiation balance for Earth's surface, there is a radiation balance for atmosphere, and there is radiation balance for Earth as a whole. Okay, put this in diagram, put the figures here, 50 here, 35 here, 15 here. You know the values here, you can do this. Okay. However, there is regional variations and okay, locational differences in energy receipt and loss. Now you can have one by one. Number one is on the surface. On the surface, what are the variations? So what happens for the polar areas? What happens for low latitudes? Okay, low latitudes 20 degree north and 20 degree south. These are a surplus. The polar areas are areas of net deficit. Something from here. B, okay, for the atmosphere. For the atmosphere, again, what is on the polar areas, what is in the equatorial areas, and what is in the low latitudes. So some figures here. And you can draw the graph on page number 38. Okay, draw the graph on page number 38. Okay, that tells you about how the maximum in the equator, maximum at the poles, there is variations at the equator. जो graph है, draw that graph of page number 38. So we are talking about the latitude aspects. Okay, latitude aspects. Having discussed this, you can mention here B, there are variations because of the nature of the surface. Okay, so high albedo where? On the ice. High albedo in the areas of, can say, is calm waters. We have got higher albedo from the thunderstorm clouds. Okay, we have got a higher absorption over the forests. We have got a higher absorption also on turbulent and tropical waters. I'm giving the structure here. Variations because of the nature of the surface. Variations because of the latitude and because of the height. I've taken them together. Okay, and the height. And this figure, page number 50. This data you take from page number 50. And then you can add a third aspect, how there are disruptions related to human aspects. Human aspects there are 4 reasons. One is disruptions because of the deforestation, disruptions because of melting ice and snow, particularly in the polar regions. There are disruptions related to constructions, okay, and disruptions related to cloud formations related to higher evaporation due to global warming. Construction, you can talk about buildings, concretes, pavements, and how all of this disrupts. You can have a case study, Arctic melting of the ice and the snow in the Arctic region. You can mention this deforestation do talk about the loss of the Amazon forest, loss of the tropical forests. Construction includes urbanization issues, and that changes the amount of insolation. Remember, the discussion is about insolation. It is not about heating in general. You must talk about the relationship of insolation with whatever disruptions we are doing. So 4 type of reasons which is disrupting. So go back to the question again, please. What was the question? Though net radiation of the globe is theoretically 0, there are regional variations in net radiation. Discuss. An introduction, 1 diagram. What are the regional variations in different places on the surface, on the atmosphere, variations because of surface, and finally the disruptions related to human aspects. Construction, cloud formation. See, when we have got more evaporation because of global warming, the clouds will also increase above the water, above the oceans. When the cloud cover increases, there will be more cloud albedo in the upper atmosphere. Even that will change, that will impact the overall insolation reaching the surface of the earth. The conclusion. So conclusion, do mention that changes in radiation balance. Radiation balance can impact climatic patterns. We can talk about the recent, bring some current affairs. The recent ice melting, the impact on the polar vortex. We can talk about the heat waves. There are concerns related to disruptions of the ocean currents, something on those lines. Turbulent, when the water is turbulent, when the water has waves, there will be more absorption. When the water is calm, still there is more reflection. The more albedo over calm waters, still waters, and more absorption in areas where there is more turbulence. And pick up those sentences I mentioned from the book. So this becomes your answer. The conclusion, the body with 2 diagrams. You have shown some regional patterns in terms of surfaces. Relate with heat budget, and you have the introduction. Tropics also getting heated, but tropics heating kitna ho raha hai? Say 30 degrees centigrade, now probably becomes 40 degrees centigrade. But look at what's happening in the Arctic region. What was -10, -20, -15 has now become 10, 15, 20. Yes, the tropic also is warming, Arctic also warming, but the change of temperatures in the Arctic region is far more, right? The rise of temperature in the polar regions is far more. That's why the overall difference of temperature is going to reduce. The gradient between the tropical and the Arctic regions is reducing. And that impacts the global circulations, including the ocean currents. So I will suggest, now listen, it's possible that they do not ask this specific question. But if you have any question on global warming, rising temperatures, disruptions of atmospheric processes, so some of these topics or discussions can be used in this. Some of these conclusions can be used in answers on global warming, rising temperatures, and whatever way the climatic processes are being impacted. So use this in answers of global warming, in answers related to climate disruptions. Do use some references around what happens to heat budget, what happens to insolation patterns, how albedo impacts. Draw this graph somewhere you can. The answer becomes smarter.